Hello everyone, we are Ucunians from Ukrainian Catholic University, and it's a big honor for us to take part in Queen's Innovative International Challenge. We are experienced team of software developers and data scientists, and today I would like to present our technical solution called Alarm.AI that will help to save city budget and, what's more important, reduce crime level. The idea is pretty simple. We get data from IoT devices that has already been installed in many modern cities, and in case of detection of abnormal or suspicious voices like gunshot, window broken, crime, etc., we send the appropriate signal to police. Why this is so important? According to a report from World Economic Forum, the total cost of crime has been estimated at $7.5 trillion. It means that every person on our planet pays $2.75 per every day. This statistics is even more impressive if we take into account that about 10% of population are living on less than $2 per day. There is strong correlation between crime level and wealth of citizens. According to statistics, violent crime cost from $300 million in Seattle to more than $5 billion in Chicago. Crime affects growth, wealth, business, tourism, etc. For example, at the beginning of 2017, tourism in Rio de Janeiro lost $320 million due to crimes. And generally speaking, every 10% of crime increasing means that tourism will be decreased by 2%. So I hope that these statistics prove the importance of this thing.
Crime is a real problem, so how technology and data can help us to deal with it? Let's start talking about our solution from mentioning key technology for smart cities, which is IoT or Internet of Things. Right now, there are billions of devices which are connected to the internet, gathering data which can be aggregated and analyzed. And it's important that a big subset of those devices will be a part of a city infrastructure. For example, in United Kingdom, till 2024, almost one-third of IoT devices will be a crucial part of smart cities. For example, utilities, surveillance, security, or even more fields which will be emerged by new smart city technologies. An obvious example is a street light. Today, LED bulbs are far more energy efficient than they were in the past. So we can equip them with cameras, microphones and other sensors. So, as IoT devices and microphones become ubiquitous, there are two questions arise. First, what we can do with this data, and second, how to process it efficiently. And the answer to the first question is deep learning. Firstly, we need to understand that we can describe our data, which is basically audio, as a big array of numbers. For example, common audio file contains 44,100 numbers. In it, it's really huge and hard to process. So engineers and researchers use spectrum features, which save all needed information but can dramatically reduce the size of the data. What does it mean? Basically, waveform can be expressed as a sum over sine and cosine waves with different frequency, and spectrum shows us importance of each frequency at a given time step. So, now we have convenient representation of our audio data, and we can apply neural network to classify it. Here you can see an architecture which is called convolutional recurrent neural network. It was originally designed to classify different bird sounds. But as it often happens in deep learning, we can apply it to our task as well, because it's pretty universal. I do not want to dive deep into detail, but I want to give some intuition why it works. Firstly, we apply a couple of convolution which helps us to extract some meaningful features. Also, we aggregate information over frequency domain which helps us to generalize. Then we apply recurrent neural network to model temporal dynamic of our data and also aggregate information over time dimension. And finally, we can apply softmax function to obtain probability distribution over our classes. Now we need to talk about data and evaluation. Data is crucial for deep learning. If you want to use your model in production, you need to collect as much data as possible from environment in which it will be used. Also, you need constantly improve your model, providing it with new samples. All of this requires time and financial resources. So our aim was to build proof of concept model to actually show that this technology works. For this purpose, we chose urban sound dataset, which contained 8,000 of audio samples with 10 different classes. Also, it was to mention that our data was imbalanced and we need to use metric which is more robust to this fact. So we can't use simple accuracy. Instead of it, we used F1 score, which is simply harmonic mean between precision and recall. So we trained our model to classify those data into 10 classes, but it's really important as theoretical benchmark. But for us, it was more important to distinguish between some certain class, for example gunshot, and other, so we can detect this, in some case, abnormal sound. Finally, we built a model which can distinguish between gunshot and all other classes, and we got even more impressive result, which you can see on this slide.
So now we have the tool for classification of the different abnormal sounds. Consider the network of microphones and let model detect unusual events for some close microphones. As we made the prediction, we need to get approximate geographic location of the crime for completely solving it in real life. For this purpose was used triangulation. Technically, as you can see from formulas, it is solving three equations based on sound delay from the source. Plot as bold green dots on the slide. Microphones showed as points M, where the first fired microphone has index 1. T1, T2, T3 are fire time of the microphones correspondingly. An additional unknown variable of R needs to fully describe the solution, and V is the speed of sound in the air. Of course, the accuracy of the solution depends on the geographic location and the quality of the microphones, but in the very first option, approximation works. As we need to communicate with an online network of microphones and communicate with the police, we decided to create cloud architecture using big data solutions. Processing center with graphical processing units gets information from the network, makes predictions, finds desired coordinates of the crime, and perform connection with the nearest police department in the very dangerous cases. Also, we can save and share obtained data with the community for making better analytics. For example, heat maps which show districts with a higher level of crime activity will be very useful for all of the citizens of the city.
How can we estimate the positive economic impact of proposed solution? Well, Alarm.AI can help us to reduce police response time, to reduce the number of false alarms, or in technical words, the number of false negatives. Let's discuss these two cases more carefully. Police response time consists of three components: process time, dispatch time, and dispatch to arrival time. For instance, in 2015, there were 8 minutes and 4 seconds average time. How can this time be reduced? In case of using our detectors, we can cross out process time because notification will be sent automatically. Additionally, there will be no delay between moment of crime and calling to police. So, we estimate reducing of response time on 25%. Why is this so important? There are strong significant effects. A 10% increase in response time leads to 4.7% decrease in the likelihood of clearing the crime.
What does it mean for the economics? The estimated savings of 25% reduction in violent crimes for the municipality budget are the numbers that you can see. They are from $6 million up to $59 million. Pretty big numbers. And what is more impressive that the reduction of one homicide causes a 1.5 increases in houses values, and the estimated increases in values of housing stocks from 10% reduction of homicides are the numbers from $600 million and up to $4.4 billion in different areas, and that's very impressive. A couple words about false alarms. According to the report of the United States Department of Justice's office, the $1.8 billion of taxpayers' money was spent to police responses to alarms activations, and about 95% of these responses, these alarms were false. And it went us to conclude that the security alarms reliability is generally about 5%, and it means for us that just according to the statistics, the reduction of false alarms about 5% causes the saving of about $85 million every year. What's next? First, we need more data to classify events like dog bark, broken window, crying, calling for the police, and other keywords. Secondly, since the data that comes from the IoT devices isn't labeled often, and the labeling is extremely costful procedure, we need to use some unsupervised learning methods in our extended model. So it is our suggestion. And also, we need a collaboration with municipalities to integrate our solution ubiquitously. And the last but not the least, we suggest to create a combined solution of Alarm.AI and the detection of suspicious and abnormal events on the video. Yeah, thank you very much.